How's it going? Welcome to another ETH Global. See some familiar faces. Welcome to Intro to Building on the Graph and Hypergraph. I'm Marcus Rein, Senior Developer Relations at Edge and Node. We're one of the core development teams working on building the graph. So today, the agenda, we're going to go into an intro on the graph. For those of you who don't know, we're going to go over the graph prizes. We're going to talk about Hypergraph, which is our new full stack app building product. And then we're going to go into the demo of Hypergraph. So what is the graph? The graph is a decentralized indexing and querying protocol. If you need blockchain data, we have many products to get you blockchain data. And here's some stats about us. One of the big ones is we have 100 plus indexers on the graph network, which is our decentralized indexing and querying network. So today we're offering $10,000 in prizes, and we're going to go into all the different ways that if you are hacking, you're able to win some of these prizes today. Here are the different prize tracks. The first one, best application built on Token API, Substreams, Subgraphs, and our MCPs. There's $3,000 for first prize, $2,000 for second. Best application built on Hypergraph. That's what we're talking about today. First prize is $2,500, and second prize is $1.5K. And the third track, best use of the GRC20 TS library. First prize is $1,000. The GRC20 TS library is the foundation to Hypergraph. We're going to be talking a lot about Hypergraph and its database and the style of its database. GRC20 is the spec beneath Hypergraph. So if you want to use the framework, that's Hypergraph. GRC20 TS is the spec beneath it. All right, we'll talk more about that in a little bit. If you are planning to hack towards any of these prices, go ahead and scan this QR code. This has docs, this has videos, this has repos, this has quick starts, this has everything you might need to get going ASAP so you could win some ETH Global prize money. So I'll wait till phones are down, and we'll keep on going. There's going to be a little bit more QRing in a little bit, but minimal QRing, I promise. Okay, got it? On the way? Kind of wants, doesn't want to. It's okay. I'll get you the link later. Okay. Okay. So one last thing. Everyone who builds on Hypergraph and submits their project gets an AirTag. So one little thing to sweeten the deal. That's always fun. And let's go ahead and talk about Hypergraph. What is Hypergraph? Hypergraph is a local first framework for Web3 consumer apps. Who here loves them some DeFi apps? All right? Who wants some more variation in their DeFi apps? That'd be nice, right? Something a little bit different. That's what Hypergraph is aiming to do. It's aiming to provide a new way to interact with data that's not only just yours, but someone else's, and have that data be composable at scale. And that's Hypergraph from a super high level. If you want to go ahead and get that quick start, that's that QR code there. That's what we're going to be doing later today, specific to Hypergraph. And so, promise, last QR code, I think. I think the last QR code. But yes, and last thing I'll say here is this is developer preview. If you are pushing this to production, wait. That's all I'll say. This is developer preview. Feel free to build, feel free to have fun, learn the principles, learn the fundamentals. This will be production ready in time. This is meant for hackathon right now. Eventually it'll be ready for full production. Cool, phones are down. A few of the Hypergraph features, let's go a little bit deeper. Privacy is a feature, all right? Anyone tries to build an app, privacy is nice to provide the users of your app. Local first, if you're building locally on your computer, it'd be nice to have that be the location of your development. And then anything you actually push, that's actually secondary, it stays local and it's fast. Full stack, it's able to have the front end and the back end combined. It's end-to-end encrypted, that's baked in. Security is in there, and then auth is already baked in. This is a full stack framework, and we mean it, all right? You're actually able to build really fast with this framework. Now, let's back up a little bit from Hypergraph just for one slide. Who here has worked with knowledge graphs? Just worked with them, or at least knows what they are. Does anyone not know what a knowledge graph is? It's kind of like mixed bag? Okay, cool. A knowledge graph is a style of a database. All right, it's a way of looking and storing data in a database. The two hallmark factors of a knowledge graph are standardized IDs and relationships are actual data. Let me go into that a little bit. If you have two different databases and they have two different styles of using IDs, to actually compose them is a complete headache. It's very difficult. But if you could have a standardized way of actually using IDs and then actually sharing that data in a functional way, you have composability potential. And that's what standardized IDs unlock. Finally, relationships are data. If I was to say San Francisco is inside of North America, is inside is the relationship. It actually provides context. And that's real data. When you're saying something is inside of something else, that's real information. And knowledge graphs make that relationship a first-class citizen, as opposed to other different database styles where it's just linking two different entities. This is actually saying the relationships are true data, okay? There's many more things about knowledge graphs, but we'll just keep it real simple right there. So let's dive back into Hypergraph. How does Hypergraph use knowledge graphs? How does it take advantage of all of these different features? Well, it first starts with the concept of spaces. Spaces are what unlocks private and public data. Some data is nice if it's public. If we have software as an entity that is actually a space, you have entities in there that could be public data. That's fine. But if we have personal notes, it would be nice if that was private. Now, the first concept I want to get through with Hypergraph is spaces could be public and spaces could be private. That already is something new in Web3, where in a framework we have the idea of saying, well, everything is public at all times. Well, the public and consumers might not like that. They do like some privacy. And having that baked in as a tool as developers that you could use privacy to offer your customers, that would be pretty nice. All right? So that's one of the nice things about Hypergraph to start with. What do you fill in these spaces? Well, you fill in entities. You put entities into these spaces, into these public spaces or private spaces. Now, entities in a knowledge graph, you have a normal entity here, just could be any concept, any data point, a normal entity here, and in between there's a relationship entity. That's what's unique about knowledge graphs. We'll go a little bit more into entities, but just know that's the unique part. That relationship in the middle creates knowledge. That relationship in the middle is actually what makes this stuff really special. So before I go on, any questions so far? That was like a high-level overview of knowledge graphs and how Hypergraph is stepping into the framework. We're good? We're good. Okay. Now, this might seem like a lot, because it is, and to synchronize all of this is difficult. If I have a certain part of the knowledge graph that I'm building, and I'm building my little database in there, and someone else in this room also has theirs, we're going to have to potentially sync our IDs, because standardized IDs is a big part of a knowledge graph. And here we've taken care of that. There's actually a sync server in there, and that makes sure that on my local computer, I have the option to standardize my local entities with whatever's on the knowledge graph. And if I can do that, I've unlocked composability between my local database, my local machine, and the knowledge graph at large. And we're actually going to see what that looks like real soon. So let's go ahead and go into a live demo. That's the same QR code as the quick start, if you missed that before. But we're just going to go through CRUD on entities in a public space and in a private space, and just contextually what that means. And this will help you get started really fast with Hypergraph. All right. So to get started, we do npx create hypergraph at latest. And let's make sure everyone can see that. Yes, they can. And we're just going to go ahead and fill in the default all the way through, just so we can actually go ahead and start building. And good job, ETH Global, with internet. Yes. Big fan of the internet stability this time. It's really good. And we're going to let this finish through. Any questions while this is spinning up? No? Okay, cool. All right. We'll go in and spin up the template. So this is just basically, we're going to look at what the front end presents in this template. Welcome to Hypergraph, your Web3 app template powered by Hypergraph. So we talked a lot about spaces, and that's the first concept I want to get through here. In a knowledge graph, when it's a public space, it's truly public. You don't have to log in to get that data. It's available to everyone. It's a public good. Let's go ahead and look at explore public knowledge. And in this location, we are in a public space. We are in crypto. That is a public space in the knowledge graph. And it has an ID. Remember standardized IDs? That's a big deal with knowledge graphs. So we're trying to be good with keeping that clear here. Now, inside of this space, there's a few different entities. There's project entities, there's DApp entities, there's investment round entities, assets. Let's just focus on projects. All right, let's just focus on, okay, we have project entities and they are filling up this very nicely. Let's see how Knowledge Graph is doing this under the hood. Let's go to the code and see how this template might be doing this. And as with data, the actual location from where you are getting the data is important. We're going to start with the schema.ts. That is the shape of our data. And then we're going to have the mapping that connects to the knowledge graph, that makes sure our local computer is able to actually communicate well to the knowledge graph. And then we're going to have routes, which actually has that data going to the front end. So how does this happen? How does projects populate from the knowledge graph? Well, first things first, we need a definition of the shape of our data. We have a project entity. And in this entity, we're getting a name, description, the X website, the X site there, and the avatar. And we can see in every one of these, we're pretty much getting those. Sometimes in the data set, it's not populating view on X because maybe that piece of data, maybe that project didn't have that written in the knowledge graph, so it's not going to be in there. And we see right there, when the X is type optional, that allows us to say, hey, if it's not in there, still let the front end run. If this type optional was not there, it would bonk and it would not actually go through. Now, wouldn't it be nice to wonder, say, hey, what else is out there on the knowledge graph? Because typically when we're developing, it's local. We're thinking, all right, what's our local database doing? But this is where it gets a little different. We can wonder, all right, this is what our local database has. It's bringing in name, description, X, avatar. That's cool. What else is out there on the knowledge graph? And I'm glad you asked. Let's go ahead and find out. If we go to the quick start and we actually check out the schema, we have the Hypergraph schema browser. This allows us to look at all the schemas that are being used out there regularly in the knowledge graph that Hypergraph is using. If we type in project, we can see right there, this is an entity that has maybe another property that we might be able to use. If we see right here, it has website. If we look back here, this does not have website, and this does. So we can go through and actually populate our front end with this data being pulled down from the knowledge graph. Let's just add website right here. And we'll let that fill in. And let's go ahead and say, all right, we've pulled that in. Let's make sure our local database is actually mapping correctly to the knowledge graph database that's being synced by the sync server. So we're in the mapping right here, and guess what? We got project. And all we got to do, very simply, is type in website and then ID. Now it auto-populated that. Don't fully trust that because we need to make sure the IDs are standardized. And this website property also has its own ID. There's IDs everywhere. There's IDs for projects, there's IDs for spaces. That's a big feature of knowledge graphs. Let's go back here and see what the website ID is. It's the EED right there. And if we do that, this project's local entity now can be composed with anyone else that's using this exact entity right there. So if anyone else is building on the knowledge graph in their local database and makes the data public, we can go ahead and compose. Isn't that cool? So let's go ahead and go back to projects and say if we want to populate that, let's just go to the bottom and where is it right here? Project.id, project name, project X, and then project website. Okay, so if it does in fact have the website, it should show right there. And there, pulled it in automatically. There's nothing else to do. That pulled that in from the knowledge graph remotely. Cool. So we know how to read. Okay, we know how to read from the knowledge graph. How do we create entities in the knowledge graph? Let's go to the C part of that formula. And if we want to create new knowledge on the knowledge graph, that's really nice. We can totally do that. That's actually baked into this concept. We have spaces right here. Now, if we want to create, we can't exactly just write to public knowledge because someone else owns this data set right here. We actually have to do a request for that. We're not going to get into that. We're going to go ahead and write to our own private space. That's because we have permissions for that. So we'll go to sign in and And we'll get the confirmation code.
Do you need to pay anything to write?
No. Great question.
You don't need to any wallets or whatsoever, right?
Not now. Nope. Nope. Okay, so we sign. The wallets are all in privy, so that's nice.
So if I want to write and make it easier for the users, I can just abstract it into the backend so they don't have to do anything?
All of this is the Hypergraph framework. If you want to go lower level and use the GRC20 SDK, you can totally play with knowledge graphs with your own customizability. This is all baked in, meant to be faster. But yes, if you want to get more aggressive and more creative, the SDK is for you right there. Yeah. And then let's create some spaces. All right. So we'll call it Marcus's private space, and we'll call it Marcus's public space. Okay. So we have a private space and we have a public space, and they're both owned by me. So I can CRUD all I want to these private and public spaces that are owned by me. Very good. We check both of these boxes and we authenticate and redirect into the app. There we go. There we go. So if we go back up to my spaces, there they are, my private space and my public space. So I have all the power in the world to say, hey, I want to add some data here. I want to go ahead and make sure this is maybe a private note or something I want to keep to myself. Well, right now we're in this template that we're just demoing. We're just creating a new project entity. That's all we're doing right here. We're just creating a project entity here, and we'll call this project 1. And we'll say project 1's description, and we'll create the project entity. And once again, IDs are everywhere, so this has the ID. And how did that happen? Let's go into the code and just look at the, this is the space ID. We're in the private space. So any space ID, any space that is created that is private is going to be using this dynamic website address. And then all we use is this little hook, which is use create entity. We have hooks everywhere baked in that you just simply populate the data, and there's going to be an ID for sure in there. And then when you're ready to actually use the next hook, you'll publish to a public space. And that's what this next hook does. So all this does is that hook hooks up to that button, and we publish whatever that data is to the public space, and we could see it's right there. All right, it wasn't there before. I should have probably shown that it was blank, but anyways. That's essentially the flow. All right, you're able to create and read right now. In terms of updating and deleting, there's a few other hooks. It is use update entity and then use delete entity. And it's really quick to modify in the knowledge graph from the front end. I'm interacting from the front end dynamically, and it's syncing all the time, as opposed to having to go to the back end, go to the front end. You're always interacting with React, you're always interacting with the front end, and you're able to build dynamically. And then if anyone else, of course, publishes data to the knowledge graph and they make it public and you have the same ID, you have essentially a big old shared database that has permissions and potentially not potentially, it will have fine-grained auth soon. Right now it's just public-private. But you have a front end that you can create based on a composable data set that is a whole new concept. So you could have, of course, blockchain data coming in from Subgraphs, Substreams, and all of the different blockchain data services that we have, and then non-financial data, just regular data coming into the knowledge graph and create some new apps that is not just DeFi, it's not just Web 2, this is something new. So let's go back to the slides, and let's talk about a few examples and ideas. Crypto projects directory, investment graph, a DApp registry, a DAO governance explorer. I think those are good places to start. If anyone would like to have some ideas, feel free to come by the booth and talk through these ideas. I'm more than happy to go into those a little bit more. And lastly, once again, I promised no more QR codes. I lied. We have one more QR code. These are the Hypergraph docs, and they will help you get started very quickly in building. We'll be at the booth, of course, today, tomorrow, and on Sunday. Build with Hypergraph. Plug in data that's DeFi data, that's blockchain data. Plug in data that's non-financial data, and learn the concepts of Hypergraph and build something new. So thank you so much for your time. I'm here for questions. Yeah.
That only exists locally, and then so is the application itself responsible for persisting that if it needs to
good question. It goes to the sync server, but it's end-to-end encrypted. So if you're creating it locally and it goes to that sync server, that's also encrypted there. The server cannot read anything. It does sync there. So
Private data is also pushed to the knowledge graph.
yes, it's just in a space that is fully encrypted.
So when you close your app and then reopen it again later, then how is that authentication?
That's what the Geo Connect. Remember I did that privy login right there? So if you okay, that's okay. Yep, there's a Geo Connect feature that allows for logging in. Yeah. Yep.
So if I wanted to use like the graph to store like private data,
Yeah.
like abstract the geo connect for the users and
Sure.
just create an app with private data, I could use like an API key or something to access it.
So I mean, essentially, the GRC20 SDK is our spec of the knowledge graph that was pushed by the team here. We've got some of the builders right here that are building that GRC20 spec and that style of knowledge graph. That's the lowest level that we have for availability. If you want to go ahead and connect whatever wallet you'd like to that, I believe that's possible right now at this point.
Yes.
Yes. Okay.
The on-chain portion of the knowledge graph, there are smart contracts, and these smart contracts have permissions for who is allowed to write data to these smart contracts. And so if you want the same account to work on your backend as what's they're using to publish data to the smart contracts, you'll have to go through GeoConnect. The way GeoConnect works is we generate smart sessions that are attached to the smart account wallet using rhinestone modules. And so that's how you're able to do more space-by-space permissions. So you would have to integrate that on your backend to make sure that you have the same session keys available so that you can write to the right smart contracts for you.
You say on chain, but where is it stored? On what chain?
So for the private data, it's not on chain at all. What we do is we use your Ethereum key pair to ride your encryption decryption keys. So so that's how you use Privy to connect, and then from there you can basically decrypt the data. So the way that that's synced is through the sync server, so it doesn't go on chain at all. When it's private, it's using CRDTs. And we could have done a peer-to-peer CRDT thing, but then you have the issue of if you're not all online at the same time, it's a bad UX. So that's why we thought having a sync server is a nice tasteful trade-off. It's better UX, so as long as that thing's available, if anyone connects who's part of that private space, they'll get the updates. So you have the real-time collaboration, and so that's just through that sync server. So it's not actually going on chain until or unless you decide to publish it to a public space. That's when it goes on chain.
Great, thank you.
Yeah.
So where is the CRUD being done? Do you have it in the cloud or?
Yeah, that's the sync server. That is the sync server. So that's what we're running right now, and it is what we are operating. Over time, when this gets more mature, it is, it's open source, so anyone can run that sync server, and it can become decentralized, yeah. Yeah.
Is there a way to verify the data? Like suppose you have a public space,
Yeah.
you want to make sure that that data is correct.
Not currently. There's not verifiability baked in. Is there any plans for anything like that?
When you say to verify, I mean, so right now, you publish the knowledge to IPFS, and then you anchor it on chain. And then for the data itself, there's kind of governance things that we're going to be sharing more about on the public spaces for kind of community governance, public governance of that data. But that's kind of different from Hypergraph.
But at the moment, is there an option to integrate, for example, community voting or something like this?
Yeah, so that's kind of for the public spaces with governance, which is available, but it's kind of it's a geo feature.
Yep. Yep. And one thing I'll add to this also is if you're looking for more spaces to dive into those data sets, go to testnet.geobrowser.io/root, and you can go ahead and start browsing around and seeing what other spaces there are. Like if I just click on crypto right there, we are in the same space, the B25. This is a space ID right there. And we were in the crypto space as well earlier. I think it was projects, and we can see, there it is, the B25 right there. So this is the same space we're in programmatically as the testnet. So go ahead and browse around and look at all the different data sets and come up with something cool.
The San Francisco space might be published on.
Yeah, let's do that. That would be,
Just go back.
it's back. There it is. Yeah, so this has another space ID. This is public space with public data and lots of information that you could tab through and build.
You can click on a restaurant.
Restaurant,
Define your own types.
there it is, trending restaurants. Yeah, so anyways, we're good? Good on time? Okay, thank you so much for your time, everybody. What was that? Okay. Okay, one more question? Yeah.
Could you mention like the censorship resistance?
Censorship,
Like a shared public
sure.
database, basically.
Sure, yeah, I mean, the data is on IPFS, so we're using that for public data. And in terms of that, the sync server, that is gonna be contained at this time, are we, yeah.
And the sync server is just for your private space.
Yeah, it's private data,
So
yeah.
for the public stuff, you're publishing that to a blockchain. So
Yeah,
it's the same
it's public,
principles as
Yeah.
blockchain.
yeah, same thing. Okay. All right, awesome, thank you guys, thank you so much.